All right, hey guys, we're going to do 4.6 today. We're going to learn how to write equations in slope-intercept form. So we're going back to slope-intercept form. There isn't a lot new here, but I want to dive a little deeper into some of the things. So let's look at the criteria here. So the criteria is we're going to be able to write equations, okay? So we're not just given an equation, we need to write them. I believe that we've done that already in the other section, but so we want to be able to find the slope and the y-intercept of a line. So we kind of need to know like what that means. And you're going to be able to use the slope and y-intercept to write that equation. So again, y equals mx plus b, where m is my slope, b is my y-intercept, I should say, my y-intercept, and let's see, if we just talk about what that means. Okay, so let me just make a y and an x here. Okay, and let's just talk about a very standard distance and time. Okay, so pause the video and ask yourself, which one, distance or time, goes on the y-axis and which one goes on the x-axis, okay? So hopefully you thought about that. So the question you really want to ask yourself is which one depends. This one's called the dependent variable, and I often ask myself that to figure out which one goes where. Like which one depends on which, right? So this is called independent. That's not as helpful. But which one depends, distance or time? Well, the distance I travel depends on how long, right? So this is going to be time, and my distance is what depends. So that's my distance. Now, over specific, the faster I go, the sharper the slope, or the faster it goes, right? Because as if time goes, if this is 1 hour, okay, if this is time in hours, I'm getting a little sloppy, I apologize. Hopefully you're listening though. In 1 hour, right, if I've only gone a little bit of distance, right, if I start off at 0 distance and in 1 hour I only went a little bit of distance, now I'm creating this line that goes about like this. But if in that same 1 hour I go a further distance, right, then I create this 1 hour equals this new distance, and I get a sharper slope. So the bigger the slope is, the bigger the number is, the more rapidly it's going to increase, and that should hopefully just make some sense. Also, when I'm finding slope, slope is equal to that y2 minus y1 over x2 minus x1. Another way of writing that, mathematicians put like this, okay? And this means delta, which means change. So the change in y over the change in x, right? So if my y went from here to here, the change in y, okay, the change in x is 1, right? In this particular point right here, I've only changed 1 on my x, but I've changed whatever this number is, call it 10, right? So that'd be 10 over 1. So my change in y would have been, if I made this 10, my change in y would be 10, my change in x would be 1, so therefore my slope would be 1. It's important to recognize that. It is asking you what is the change, okay? So even if I picked 2 points on this line, 2 points, okay, I'd want to know, well, what's my change from this x to this x, and what's my change from this y, let's do a different color, to this y, right? So that's change. And then the y goes on top. Rise over run. The y's always go on top. Okay, so hopefully that's not too much talking. I just really want you guys to understand this idea of dependent, whichever one depends on the other. And I want you to understand that this y2 minus y1 and x2 minus x1 is basically telling you the change. How much did it change? That's why we see these weird triangles that they're forming in our graphs. It's trying to show you this change. So let's do a couple, and there's one of those odd things. Okay, so we know that the change, I'm not even going to do the y2 minus y1 because I want to continue on that thought. I wasn't planning this. So my change in y is -3, and my change in x is 2. So if I'm going to write this in slope-intercept form, I just need to know, well, it was -3 over 2, which means it stays -3/2, x, and where did it intercept the y? Well, it intercepted the y right here at 0, 5. So I use plus 5 because it is the positive 5. If it was on the bottom down here at -5, I would use negative. This would be -5. Okay. Now, then you're going to get some problems that look like this. These are a bunch of points, 4 points, on your graph, okay? And we just need y equals mx plus b. So I just need to figure out what's the slope and what's the y-intercept. So think about a graph, okay? So this is where it intercepts y, let's say. It doesn't, like, this isn't necessarily where it does in this problem. But let's say this is where it intercepts y, or in this case, probably down here. This is where it intercepts y. So y is how much up and down a number is. Your y, so it's x comma y. And the x value is how much it goes right or left. Well, how much right or left, what is my value of x when it intercepts y? In either one of these two red points that I've made, what is the value of x? The value of x is 0, right? So in this top one, that might be 0, 10. And in this bottom one, that might be 0, -3, which is exactly what I have here. So what is my b? B is my y-intercept, right? So what is my slope? This is when x is 0, y is -3. That is literally my y-intercept. So when you're doing the problems that look like this b, you're going to look for the one that has an x value of 0. And this value is my b. So I already know that I'm going to have -3. Now, what is my slope? Okay, so I can pick anything I want. And I'm going to pick these two because I've done quite a few of these, and I recognize that it's going to be easy to subtract and stay positive if I subtract this minus this, and then this minus this. So my m equals y2 minus y1 over x2 minus x1. And I'm going to make that 7 minus my other y. Notice these are my y's, these are my x's. 7 minus 2 over 6 minus 3. Remember, it doesn't matter which one. Let me erase a little bit of this stuff. It doesn't matter which one of these 2 points I choose, and it doesn't matter which one I made y2, but since I made this 7 y2, this 6 has to be my x2. Does that make sense? Okay. So we have 7 minus 2 is 5, 6 minus 2 is 3. So my slope, if I go back up here, is equal to 5/3. And I'm done. 5/3 x minus 3 is my equation. Alright, so the last thing that it wanted us to do was learn how to use this in real life. Okay, so engineers are digging a 35-foot long tunnel at a constant rate, also known, the only reason you know at a constant rate is that basically means it's a linear equation where a slope is that rate. So, this is, oh, sorry guys, hitting the wrong buttons here. So this constant rate means that it has a slope and it is a linear equation. Otherwise, if it wasn't a constant rate, it would look like this, right? If the rate changed. So it's a constant rate, so we have a linear equation. All right, so engineers are digging 3,500 at that constant rate. After 4 months, 4 months is my time. The engineers still need to dig 1,500 feet. Okay, so this one's a little tricky. So if I think about it, I basically have this distance. I have a distance of 3,500 and 1,500, and I have time. So we actually did this. So which one's my y? Let's draw this. I like to draw. So which one's which? So my distance is my y, because the distance depends on how long. The amount of depth I've dug depends on how long I've been digging, correct? Okay, but in this case, I'm trying to dig a hole. So my distance over time, well, where did I start? At time 0, where did I start? Well, I still had, how much more did I have left to do? So we might even say that left is distance left. Okay, so this would be 3,500. And it's the point, actually, it's the point, let's do that, it's the point 0, 3,500, right? Or another way to look at this is, what was the change between 3,500 to 1,500? We don't even need, in this case, it's super obvious that I just changed my y distance. So let's just think of it like this. I'm gonna stretch you guys here. Let's do the delta y over delta x. So the change in y is 3,500, and now with 4 months left, we still have, so the point 4, we still have 1,500 feet left. But let's not even do the y2 minus y1, x2 minus x1. What is the change in y? The change in y is 2,000. But it was negative 2,000 because we went down, right? We're going down. This is our line. And at some point, we're going to be done digging. Okay, does that make sense? That's what my intercepts mean. So I started at 3,500. Eventually, at some point in the future, which we're probably going to solve for here, I will be done digging. I will, at some point in time, I will have 0 left to dig. Okay, so let's go back. Sorry, I'm off track here. How much time did it take to get to this? What was the change in x? The change in x was 4, right? It went to 4 hours. Or 4 months, right here. 4 months, after 4 months. So therefore, my slope is negative 500. Okay, so let's plug this in. Y equals negative 500x, and what's my y-intercept? Boop, boop, right here. Blah, 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 blah. Sorry, I'm losing my pencil right here. It intercepts y at 3,500 plus 3,500. Sorry, I'm switching colors here like crazy. Okay, so that's it. I'm ready to go. Now, but what's my question? I always need to keep track of what's my question. So, how much time... So at what point in time am I done? That's what I was expecting. So what is this point is what it wants to know. Okay, so I could do this a couple ways. One way is I could solve this equation for I could solve this equation for standard form, but that is definitely the hardest way. So what value is y at this point of x? 0, right? So let's do that. This is going to be kind of crazy, but let's make y 0. So when y is 0, what is x? So all I have to do is solve for x, and I will be done. So let's do that. We'll draw our line here. We'll subtract 3,500 from both sides, because whatever you do unto one side, you must do unto the other. These cancel. I have negative 3,500 is equal to negative 500x. Divide both sides by 500. Negative 500, I'm sorry. And x is equal to positive 7. So therefore, the answer is 7 months. It takes 7 months to dig this 3,500 foot long tunnel. All right, so hopefully that made sense. If not, I highly recommend you watch that again. Understanding change in y, change in x, plugging it in, understanding how these intercepts work is super important. This problem is super important. That's why I took extra time on it. All right, guys. See you next time.